Okay, so we're trying to figure out what our coefficients are going to be. So for me, it just starts out easiest by just saying kind of like, okay, let's take it down to 4 to start. We'll see how that goes. And here's my R1, here's my R2. So for n equals 0, I'm looking at C0. And I want to know, does anything here tell me what C0 is? I know that C2 is 0, and I know there's a relationship between terms up to and minus 1. But since I don't know any terms yet, when I've gotten to the point C0, I don't know anything until I reach C2. I'm going to go ahead and say C0 is one of my unknown coefficients. So that's my first unknown. And then I can go ahead and proceed to n equals 1, C1. Again, I do this check. Nothing really tells me anything about C1. I don't know anything until I reach C2. So C1 is my second unknown coefficient. I know it seems kind of silly that I did that instead of just saying C0 and C1 are always unknown. That won't be true. Sometimes this relationship will tell you C0 or C1, so you need to be careful. Now I'm at n equals 2, so I say C2, and I check my relationships. C2 is 0 according to R1. And now I'm wondering what C3 is. So R1 doesn't tell me anything about C3. In fact, R1 is never going to be useful to me again at this point. And then I already have my two unknowns, C0 and C1, so I can't call C3 unknown. I must use this relationship to tell me what it is. So what's going to be helpful here, I think, for you all is to actually write this in terms of k's, because k will be its own letter that doesn't always have to line up with the n value you're currently at. That might save us some confusion down the line. All I'm doing is renaming it. I'm not changing anything about it. So if you don't need to rename it for this to make sense to you, don't worry about it. But if having like overlapping meanings for letters confuses you, this would be the way to clear that up. So if I'm looking at C3, I want to know what it is. That means that I plug in R2. That's the only thing that I can use. And that'll tell me what CK plus 2 is. So if I want K plus 2 to be equal to 3, I need to plug it in for K equals 1. So then that would tell me that C3 is equal to minus C1 minus 1 over 1 plus 2 times 1 minus 1. Oh, good news. That wasn't K minus 1, that was K plus 1. I probably just erased that minus sign a second ago. Okay, so that's minus C0 over 1 plus 2 is 3, 1 plus 1 is 2. And there's going to be a temptation to multiply 3 and 2 together and get 6. Don't do that. I just said don't do that, and some of you are going to do that anyhow. So I'm going to say again, don't multiply these numbers together. We eventually want to find a pattern for what's happening. And if you multiply the numbers together, it's harder to see the pattern. So do not simplify. Now we're on n equals 4. So C4, again, we're going to be using R2. Plug in R2 for, we went up 1, so we know we're going to have k equals 2. We could also think through if we want k plus 2 equals 4, that means k is 2. Basically, we want the number on the left-hand side to match what we're trying to become. So that means C4 is minus C k equals 2, so 2 minus 1 over 2 plus 2 times 2 plus 1. So that's minus C1 over 2 plus 2 is 4. 2 plus 1 is 3. All right. To me, it's not really clear yet what the pattern is, so let's keep going. So for C5, oh, not C15, we're going to do R2 with K equals 3. So we've got C minus C3 minus 1 over 3 plus 2 times 3 plus 1. So that's going to be minus C2 over 5 times 4. But C2 is 0 from right there. So that's actually just 0. C6 is going to be minus C4 minus 1 over 4 plus 2 times 4 plus 1. So that's going to give us minus C3 over 6 times 5. So that's going to be, we found C3 right there. So it's minus C0 over 6 times 5 times 3 times 2. So C0 over 6 times 5 times 3 times 2. And maybe a pattern is starting to emerge for you, but we'll go ahead and compute the next one and maybe one more after that just to make sure that we really know what's going on. So let's see. We've got C7 next. That's going to be minus C5 minus 1 over 5 plus 2 times 5 plus 1 equals minus C4 over 7 times 6. But we already found C4 up above, so it's actually minus C1 over 7 times 6 times 4 times 3. Or C1 over 7 times 6 times 4 times 3. And then when we go up to n equals 8, hopefully you've kind of guessed at this point, C8 is going to depend on minus C6 minus 1 over some stuff. So that's going to be minus C5 over some stuff. But C5 we already saw was 0. So we're going to have this pattern of two terms. One depends on C1, one depends on C0, then a 0. Things that depend on C0 and C1, then a 0. Things that depend on C0 and C1, and then another 0. So now we can say a pattern starts to emerge. And that pattern tells us that we're going to have, if y we said was equal to C0 plus C1x plus C2x squared plus C3x cubed, so on and so forth, then what we're going to have is y is equal to C0 is C0. So we leave that as it is. Plus C1 times x. C1 is just itself, so we leave it as it is. Plus C2 times x squared, that term goes away because C2 was 0. Plus C3 times x cubed, we're going to use this relationship. So that's actually going to be minus C0 over 3 times 2x cubed. And then C4 is going to give us minus C1 over, it must be 4 times 3. Yep, minus C1 over 4 times 3, x to the 4th, plus 0 x to the 5th, plus C0 over 6 times 5 times 3 times 2, x to the 6th, plus C1 over 7 times 6 times 4 times 3, x to the 7th, so on and so forth. So this is a mess. But let's think about what unknown constants used to mean to us. We used to write y equal to c1 y1 plus c2 y2. Now we've got these two unknown constants. So we can go ahead and write y equals c0 times 1 minus 1 over 3 times 2x cubed plus 1 over 6 times 5 times 3 times 2 x to the 6th plus a bunch of stuff plus c1 times x minus 1 over 4 times 3 x to the 4th plus 1 over 7 times 6 times 4 times 3 x to the 7th, so on and so forth. And so these things in brackets are fundamental solutions. Oops, sorry, fundamental solutions. And the general solution is just this thing. Next class, we'll think more about actually what those fundamental solutions look like, but you're learning a lot of stuff right now. So we'll kind of leave it right there for this example.